Okay, so hey guys, this is Code Time, and today we are going to do D problem, that is Xor-gun. So in this problem, we have been given an array which is in non-decreasing form, that is in sorted order. And what we can do is, in one step, we can select two consecutive elements, and let's call them x and y, and we can replace them with their XOR. And what we need to do is, by doing these minimum operations, we need to convert it into basically it no longer be non-decreasing. So let's see how we can approach this problem. Okay, so these are the some points which we need to know before solving the problem. So first of all, we need to know the property of XOR, which is if there are two, if I take XOR of two same numbers, and this equals to 0. Okay, now the very first point is, if suppose in this array I have a of I, if MSB of a of I minus 1 equal to MSB of a of I and MSB of a of I plus 1, MSB here is most significant bit, then basically if I perform this operation, that is if I select two numbers which are I and I plus 1, then their XOR will become less than the I minus 1th element, and we can hence get our answer. So let's see with the help of example what I mean to say. So suppose a of I minus 1 is equal to 1 0 0 0 0 0, and a of I equal to 1 0 1 0 1 0, and a of I plus 1 is equal to 1 1 1 1. Now here the MSB, their MSB is same as we can see, but if I XOR I and I plus 1, then their XOR results in 0 1 0 1 0 1, which is less than a of I minus 1. Hence, with the help of example, we have understood that if that we have found these three numbers a, b, c, in which a is less than b and b is less than c, but a is greater than XOR of b and c. Now, in the given question, we have been given constraint that n is less than 10 to the power 9. So the maximum bits in a number can be 60. That can be calculated with the help of this formula. So now you need to understand that if there are if basically the number of elements in this array are greater than 60, then I can always find out three numbers, that is a tuple of three consecutive numbers which satisfy this property, that a is less than b less than c and a is greater than b XOR c. So I can say if n is greater than equal to 60, then my answer will be equal to 1. But suppose n is less than 60, then I have no choice but to calculate all the possibilities that can be encountered in my answer. So if n is less than 60, what I can do is, what I basically need to do is, suppose a0 a1 till an is my an minus 1 is my array. Now what I have to do is, I have to find two such regions whose XOR, which basically satisfy this property, that is by doing these many operations in left and these many operations in right, I can basically calculate left is greater than right. I hope it's clear. So for this, what we need to do is, we need to make a prefix array of XORs for calculating XOR in linear time. So basically I can calculate XOR of AI from AI to AJ in basically linear time. And for now, after calculating this, what we need to do is, we need to run three loops. As I can see, I have to run a loop that is basically I, and I will be run from first element to last element, and then it will be j, which will run from ith element to the last element, and then it will be k, which will run from j plus 1th element to the last element. And for calculating the left region, what I can do is I can take prefix of XOR of prefix of j, which is nothing but XOR of a0, XOR of a1 till aj, with prefix of I minus 1. In this way, this part, like a XOR of a0 till XOR of a minus 1, I minus 1, will cancel out, and the remaining part is this what I will get as a left region. Similarly, I can calculate right region as well, and if my left is greater than right, then basically I have found out my temporary answer, which can be my answer. So for that, how many operations I actually did, that will be actually the total number of XORs from I to K are K minus I, right? And but here you can see we are calculating XOR from I to J and then J plus 1 to K. So here one XOR is being added extra. So what I have to do is total number of operations for this part will be K minus I and minus 1 for basically this extra XOR. So now let us look at the code, which is pretty straightforward implementation that we discussed. So here I have calculated basically declared a vector of n plus 1 size, and I have initialized it with 0. Then I have taken input as prefix of I, and what I am doing is I am calculating a prefix array of XORs, for which prefix of I will be equal to prefix of I XOR with prefix of I minus 1. Now, as we discussed, if n is greater than 60, then my answer will be 1. That is, I can always found a triplet. But else, what I need to do is I need first loop from I equal to 1 to n, then second loop j equal to I to n, and third loop from j plus 1 to n. I calculate my left region. Oh, here I have shown left region as prefix of j, that is this, XOR with prefix of I minus 1, that is this. So this will be my left region. My right region will be prefix of k XOR with prefix of j. So this will be my right region, and if I found left is greater than right, then this is my temporary answer. So I can basically calculate answer equal to minimum of the current answer, and then the number of operations in this case. So in this case, number of operations will be, as we discussed, k minus I, and I will subtract minus 1 for this extra XOR. So that's how we can calculate. Let's run this code, and yes, it passes the case. Thanks. So I will attach the code in the description. Thank you so much for watching.